In this question, we will find the pattern to write this in summation notation from k equals 0 to infinity. We see even exponents on x. Even is 2 times k. So I'd like to say x to the 2k, but that doesn't quite work because if I plug k equals 0 in, I'm going to get x to the 0, which is 1. We need the very first term to be 2. How do I get even, but still have this 2k? Well, I'm going to shift things over by 2 to get to the next even number. Now when I plug k equals 0 in, I get x to the 0 plus 2, which is 2, just like I need it to be. When I plug k equal 1 in, that will be x to the 4, just like I need it to be, and so on. The denominators are factorial. They go up by 1. I'd like to say k factorial, right? So that would be 1 factorial, then 2 factorial, and 3 factorial, and so on. But that doesn't quite work. We need to make sure that it starts at the right place. So I can't just say k factorial. How do I make it so that when I plug 0 in I get 5? Well, I say k plus 5. Then when I plug 0 in, the very first term is 5 factorial. Plug k equal 1 in makes a 6 factorial. So we'll have a k plus 5 factorial. Finally, we need an alternating. Alternating is going to be negative 1 to a power. If I start with negative 1 to the k equals 0 makes negative 1 to the 0, which is positive 1. So that's not quite right, because I need the very first term to be negative. And so the way I get that is by adding a 1 up here. Now when k equals 0, that's negative 1 to the 1, which is negative. And so the first term is negative, just as we need it to be.